So these questions are just questions that I've randomly found. I haven't done them with any of my pupils. I have probably done similar questions with you before. So what I'd like you to do is I'd like you to have a go at the question, pause the video before I carry on. I'll give you about 5 seconds before I give the answer. If you get the answer correct, great. Just move on to the next question. There's going to be about 20 minutes worth for each bit. The best possible outcome is you actually do the question. Obviously, I can't, if you're out and about and you've got other things going on, just go through and watch the solutions. You'll get some sort of benefit from them. If the first batch of questions are foundation bonus ones, they are, if you're doing foundation, the most important thing is stuff like multiplication, division, bid mass, fractions of an amount, percentages, ratios, that sort of stuff. Make sure you're all fully aware of those ones. These questions are just bonus ones. There's some pretty tricky one in particular. It's pretty tricky on there that I can think of. And this might become a series depending on how much time I get. For the higher pupils, same goes really. If you're looking for those grades 7, 8, and 9s, this is perfect because these are most of the questions I've aimed for those areas. There's some really tricky questions on there. One in particular, again, is really, really tricky. Just go through and do your best with them. Pause the video, have a go at them, see how you get on with it. If you get them right, woohoo. If not, don't worry about it. It's fine. Yeah, like I say, with those for the foundation pupil, for the higher pupils, the main thing you want to be focusing on stuff like expanding triple brackets, factorizing harder quadratic algebraic fractions, that sort of stuff, cumulative frequency and box plots, those kind of easier marks, and some of the crossover foundation stuff before you go into these high end, like end of question topic questions. They're going to differentiate the grade 6 pupils from the grade 9 pupils. All right, good luck, guys. Hope you're going all right. Bye. Right, next question. Pause the video. Answers coming up now. Did you get it right? If you didn't get it right, I'm going to show you how to do it now. Okay, so this is a tricky question. It's probably a grade 8 question, maybe grade 7. You need to be able to be looking at working on. We're going to take each bit. Now, there's quite a lot of ways. I've chosen this question because there's quite a lot of ways that you can make marks. We've got 4 marks. So how are we going to get some marks from here? Well, if we take each bit individually first and foremost, and we break each problem down. So here we've got 5 and 4/9 to the power of a minus a half. So we've effectively got 2 parts. The first thing we need to do is we need to turn that 5 and 4/9 into a top-heavy fraction. So we've got to go, okay, right, well, it's going to be out of 9. So we multiplied the whole number by the denominator, which gives you 5 times 9, plus the 4, which gives us 49 over 9. Should be pretty basic stuff for most of you, right? And here we're going to take the 49 over 9, and we're going to put it to the power of a minus half. Okay, well, we need to split this minus a half effectively into 2 parts. We're effectively saying timesing it by minus 1 times by a half. So when we put, because there's 2 parts. Now, when we put something to the minus 1, if I just bring this up here, when we put something to the minus 1, what we effectively do is we reverse the fraction. So we flip it. If it's a whole number, we put it as a half. But here it's a fraction. So here we're going to say, well, instead of 49 over 9 to the minus 1, well, that's going to give us 9 over the 49. So here we then have got, once we've done that, we now have got to go and work out this part. Let's go and change colour for that. We're going to say it's going to be to the half. So then we've got 9 over 49 to the half. Not to the minus a half, James, to the half. Right. So that the half is a square root. It means effectively square rooting top and bottom. Hopefully you already know that. If you don't, have a look into it a little bit further. Google it and all that jazz. Maths Genie. Right. So we're going to look at this bit here. So it's going to be, we basically, when we square root a fraction, we effectively square root at the top and we square root at the bottom. Something a lot of people forget. So here we're going to have 9, which is going to give us 3. The square root of 9 is 3. And the square root of 49 is 7. Okay. Right. So we've got ourselves 1 mark. Quite a lot of work for 1 mark, but hey ho. Right. Let's go and just move this back a little bit. Let me just move this over and let's go on to the next bit. Okay, so let's change colours because I like to change colours. Make it look all nice. Right. Okay, so the next bit, we've got times by 4 and 2 thirds. Okay, that's really relatively basic. That's just going to become 4 times 3 is 12, 14 over 3. Okay, so we've got that bit there. So I also forgot to underline the answer, so let's just underline. So that bit there, just to make it easy for the examiner. We've then got this 2 to the power of minus 3. So I'm going to put that there. So we've got 2 to the power of minus 3. So we've got to think about that in terms of, again, in terms of minus 1 times by 3. So if we think about it, well, it's going to be, we've just mentioned earlier that when we have a whole number and we put it to the power of minus 1, we effectively make it 1 over that number. So if we deal with that bit first, the minus 1, well, the minus 1 is going to give us, if I just put that across there like that. Okay, so for the minus 1, it's going to be 2 to the power of minus 1. So that gives us 1 half. Okay, then if we deal with this next part of the next, we're going to have effectively 1 half cubed. Now again, same as with the square roots, we cube the top and we cube the bottom. Fortunately though, because 1 cubed is effectively just itself, it's going to be 1 over 8. Okay. Right, now comes the bit that's, I think a lot of pupils will get that. If you're aiming for a grade 6 or 7, you probably will get at least some of that and you're looking to get marks. Now remember, each bit is potentially going to get you a mark, and I really can't emphasize this enough, right? So that definitely would get you a mark. This might get you a mark. This almost certainly get you a mark. Now the final mark is going to be likely for just doing the actual question. So let's rewrite that whole question. Let's do that in, I don't know, let's do it in a blue maybe. Let's go and so let's do the whole question. Let's do it in a blue. So here we've got 3 over 7 times by 14 over 3, all divided by 1 over 8. Looks horrible, right? What we've got to remember is this bit here, we've got to do the top bit first, and then we're going to come back to this 1 over 8, which might be throwing some people out. Now, 4 times, when we multiply fractions together, all we do is we just literally multiply the tops and we multiply the bottoms. Now, 3 times 14 is the same as 6 times 7, so that's going to be 42. 42, and then 7 times 3 is going to give us 21. So I've just basically done just this bit. Okay, now we can now simplify that clearly, which is wonderful. That's going to give us 2. All right. Now let's rewrite that again. See how many rewrites I'm doing. I'm not really thinking that much. I'm just going to keep rewriting it. Now, again, it might look, if you looked at it on big whole picture, it looks really complicated, but I'm just doing lots of little small rewrites. So here we're going to take the 2, and we're now effectively, remember that over 1 over 8, that basically is effectively dividing. So we're effectively dividing by 1 over 8. So this should be really relatively basic for people. Remember, when we're dividing by 1 over 8, we're doing effectively KFC. So we're going to go 2 times by, because we change the sign, we keep the first value, we change the sign, and we flip this fraction. So we do 4 times 1 over 8, which gives us a value of 16 as required. Now, I appreciate it's a bit tricky. The main thing is look at all the ways to get marks. Make sure you show anything you can in the exam. I hope that makes some sort of sense. Okay, tricky probability question. The answer's coming up in a second. Pause the video if you want to have a go. Answer is red counters is 12 and green counters is 9. Right. So did you get the answer right? Hope you did. If you didn't, let's have a look and see what we can do about that. See if we can get this question correct. Right. So there are red and green counters in a bag. A counter is taken out at random from the bag. The probability the counter is green is 3 over 7. Okay, so that's the first bit of information that we can use, all right? So we know that green clearly is equal to 3 out of 7. But if there's green and red counters in the bag, that means that that's effectively like a proportion. So what we could say is we could almost write it, we could write it as a ratio. We could say green and red. Well, that's going to be 3 to 4. So, but we don't know, that gives us the ratio. It doesn't actually give us how many there are in that particular situation. It could be, we could have 6 and 8, green and red. But we could also have, just as easily, we could also have 12 and we could also have 16. We just don't know. We just know that that's the proportion that they're going to go up in. So how do we do that? Well, what we do is we give that value a letter. Now, it doesn't matter what letter we use, but generally with algebra, we like to use X. So what I'm going to say is I'm going to say that the green is going to be equal to 3x, and the red is going to be equal to 4x. Right, so let's go back and make sure we've not missed anything. So we've got the green is going to be equal to 3x, and the red is going to be equal to 4x. Yeah, that looks right, because in total, and we'll put the total as well, because that's important too. The total, clearly, well, that's going to be 7x, because we also don't know how much that is going to be increasing by. So we probably won't get any marks at this point. It's just kind of the setup, unfortunately. The next bit we'll have a look at is going to be there's 2 more red counters and 3 more green counters put into the bag. The probability that the counter is green is 6 over 13. So we're interested in the probability of it being green. So we could write it like that. Now, this isn't actually too as bad as I first thought when I read the question. So what we're going to do is we're going to basically, well, if we look at it, when we're thinking about probability, we're thinking about the something over the total, same way as we would with a fraction. So now what was the fraction now do? Now if we keep the green fraction, let's go to the total first. Actually, excuse me. Let's do the total first. Right, so it's going to be 7x. And we've got 3 more green counters, so plus 3. And we've also got 2 more red counters, so plus 2. Right, so that's going to be the bottom bit. Now the top bit, we've got 3x and 3. Okay, so 3x plus 3 and the bottom. Okay, so I hope that kind of makes sense. Basically, we've got the algebra component that we got at the start, and then 3 more have been added to it. So we say 3x plus 3. And the bottom bit, we're going to have 7x, because that's the total, and then we're going to have an extra 3 red and 2 blue on the bottom. We can only count the green ones on the top, because that's all that we're interested in, which gives us now an algebraic probability of 3x plus 3, because we can simplify that, clearly, and we're going to have 7x plus 5. Okay, right, so we've got that algebraically set up. Next thing we've got to do, the probability the counter is green is 6 and over 13. So what we can say is, well, that means that they're going to be equivalent. They're going to be equal to each other. So we're going to write that out. It's going to have 7x plus 5 equals 6 over 13. So right now, the next thing we can do is we can effectively multiply this out. We can do some cross multiplication. If you're not familiar with this, we're basically multiplying both sides by 7x plus 5 on the top of both sides to cancel out the 7x plus 5, and we're multiplying the 13 on both sides, which cancels out the 13, but we're left with it on either side. Now we're going to end up, it's called cross multiplication. Again, look it up on you, Google it. This is the sort of thing that's going to help you learning, but I'm just presuming that you're familiar with that notion. Right, so here we're going to have 30x over 3 equals 6, 7x plus 5. Okay, well, we're going to have to expand those brackets out. So 13 times 3 is 39x. 39. And here we've got 42x plus 30. Right, everything I believe looks right so far. We've now got a relatively straightforward-ish unknown on both sides. We've got to solve. We've just got a minus 39x from both sides to solve this, to get x's all on the one side. So we're going to get 39 equals 42x. If I just bring this up over here. And plus 30. We're going to take away 30 from both sides. And that's going to be 9 is equal to... Oh, hold on a second. I have missed out. That's not 42, James. That is 3. It's going to give us 3x. And then, well, you can probably see from that our x value is going to be equal to 3. Now, before we jump up and down and go, hey, we've got the question right, we have found the value of x. What is the question actually asking us? Well, the question is asking us what value... Find the number of red counters and number of blue counters in the bag originally. So we've just got to pop that back into these two equations. So it's really simple to get the last few marks. So the red is just going to be 3 times 3, which equals 9. And the blue, the green is going to be 4 times 3 equals 12. And that is the answer, as we did. I hope that makes sense. Tricky question. Make a note of it if you haven't. Make a flashcard. On to the next one, if there is one. Okay, so we have a really tricky question here. I'm just going to give you the answer. Pause the video if you want to have a go. It'd be really good for you to have a go, see if you can get some marks. It's worth 5 marks. The answer is a half. Right. What I am going to say is I'm going to go through this, but it's quite long-winded, so there's going to be certain areas I'm just going to gloss over, presuming that you have that prior knowledge. Because to be able to attempt this question, you've got to have some sort of prior knowledge about, say, expanding brackets and stuff like that. So the first thing is, well, the area which you will get in the exam is pi r squared of a circle. Right, so we need to use that to find part B. Now, part B looks the easiest, which is why I'm going for part B. So here we're going to have the radius squared times by pi. It's better to think about it like that. So effectively, well, what is the radius? Well, the radius is 2 minus 2 all divided by 2. Okay, it's that bit there. Now, because it's half the diameter, so it's going to be 1 minus x. Okay, so we've got to do 1 minus x squared times by pi. And that is going to give us, well, effectively that is this. It's a double bracket, and it's just a case of expanding a double bracket. So relatively straightforward first bit. 1 minus 2x squared, 2x plus x squared. And effectively, it's all going to get multiplied by pi. We'll leave that bit till later. Let's double underline that, because that normally the pi's will cancel out in an uncalculated question. Right, next bit is we've got to work out the segment. So if we draw out the segment, well, effectively we've got the 45 degrees, and we've also got this bit here. So we've got 5x minus 1. Okay, so let's go and have a look at how we work that out. Well, the segment is going to be 45 over 360 times by 5x minus 1 all squared. Okay, so let's simplify that. Well, 45 over 360, take my word for it, will simplify down to 1 over 8. And this is going to give us 5 over 5x minus 1, 5x minus 1. And we forgot our pi at the end as well, because we do need to make sure we keep that involved. So that's going to give us 1 over 8 pi. And we're effectively going to have this double bracket of 25x squared minus 10x plus 1. Okay, so that's the segment done for now. Now, we basically need this other bit of the segment. We need this bit here, this bit at the front, because what we're going to do is we're going to take that away to find out what the area of A is. So let's go and have a look at this bit. This really is truly a long-winded question, right? So we'll say small segment. We'll just put small seg. And here we're going to go, okay, well, that's going to be, well, 1 over 8 pi. We'll just leave it like that before. We're going to skip a step, so to speak. And we're going to have, it's going to be, well, this time we're just using just this bit here. So it's going to be 3x minus 1, 3x minus 1. And we'll go straight to the double bracket just to save a little bit of time, because this is a really big question. Yeah, so it's 1 over 8 times, and we're going to do 9x squared minus 6x, because we're going to do it twice, plus 1. Okay. Right, so we now have got to find out what this bit is. There's just so many colours there's going to be on this. It's going to be very colourful. We need to find out what this green section is, which obviously is a section of A. So how do we do that? Well, we've got these two values, which I have, as usual, forgotten to underline. Do not do that in the exam. Make sure you underline it and make it clear for the examiner. So we've got these two values, and we need to basically take one away from the other. And because we've left it in a certain format, we actually can do it relatively simply. So we can actually think about it. So we'll just call this A. And well, A is going to be 1 over 8 pi. And what we can do is we can put a little square bracket and just focus in on the what's in the brackets. So we've got 25x squared. And let's do it this way, right? So 25x squared minus 9x squared. And then we're going to have 10x minus 10x minus 6x squared. Be very careful there. And then we're going to have plus 1 minus plus 1 minus, well, plus 1. We might as well keep to the bracket theme and expand that. So let's just leave that 1/8 pi at the end. And here we're going to have, well, this is going to cancel down. So this is going to give us 16x squared, which is probably going to help us somewhat. We then are going to have minus 10x plus 6x because we've got a minus and a minus. This is going to give us minus 4x. And then here, those two bits there are actually going to very nicely just cancel out. So they're just going to go away because of plus or minus 4. Right, okay. So here we can effectively try and divide through now by 8. So that's nice for that bit there. So that bit there is going to divide through by 8, which is going to give us 2x squared. And then the minus 4 is going to divide through, and that is going to give us minus a half x. And we'll now stick the pi on at the end because it's normally you have the pi at the end of it. Okay, so, right, you think you're finished? No, we're not finished. This is just a mammoth question. This really is a big question. Okay, so let's have a look at the next bit. So the next bit is, let's go and change our color. And here, the next bit, we're going to do, right, we've basically got to make these values equal because we have our value up here, which is this bit here, and we have our value up here. And that will allow us to find out what value of x is. So let's just take these two values. So we're going to have 2x squared minus a half equals 1 minus 2x plus x squared. Okay, now they both are equal to pi. I'm going to put this on at the end. However, that will just cancel out because there's one pi on each side, which is why we kind of don't really worry too much about the pi. Right, now what I'm going to do is I'm going to write this up over here on the right because I've completely run out of room. Here we're going to have 2x squared minus a half x equals 1 minus 2x plus x squared. And we are going to have to basically take that away from both sides. So it's going to give us, so here we're going to have x squared minus a half x. And here we're going to add minus a half x equals 1 minus 2x. And here we then are going to have to add this to both sides. So we're going to have to add the 2x to both sides, which is going to give us x squared plus 3 over 2x equals 1. And then we are finally going to have x squared plus 3x minus 1 equals 0. Right, now I'm hoping you're going to be able to spot that this is going to be a little bit tricky to solve. So what we're going to have to do is multiply everything on both sides by 2. Clearly nothing will happen to the right hand side. Just to have a go. So here it's going to be 2, 3x. Sorry, there's a bit of lag on my pen, unfortunately, due to the video. Right, so that gives us that. So we now have got to solve out what this is. Now, this is going to be using, we're going to basically say what works, what multiplies. So we wake up, what multiplies together to make minus 4, but adds together to make plus 3. So it's going to be plus 4 minus 1. And once we've done that, what we've got to do is we've basically got to take that and then we've got to put it in both as a coefficient of 2. And 2x minus 1 all over 2. It's going to cancel that bit out. It's just going to give us x plus 2 there. That makes some sort of sense. Right, this is now, because I've got so little room, we're going to move this over here. So it's going to be 2x minus 1 and 2x equal to 2 equals 0. So this bit here, this first value, is going to be equal to x is equal to a half. And the second value is going to be equal to minus 2. So what we have to say is we have to say that basically this one doesn't technically exist because it's a negative value. So we say it is negative, so not valid. And this is our answer. Wow! Right, okay. So that is how hard the actual exam can get. I really hope that you manage to get some sort of marks on that, even if you're looking for a grade 8, grade 9. You want to be looking to get marks on these questions. Yeah, I hope you got something on it. Right. Good luck, guys. I really hope it goes okay for you on your non-calculator paper 1. Good luck. Bye.